All right, so my name is Steiner. I work for the Chrome team. I'm here today to talk about built-in AI APIs for the web, exclamation mark or question mark, we will see. If you want to add AI to your web application, you have a number of options. But before, let's actually think of an application where this would maybe make sense. So imagine you were to build an application that lets people record their ideas and organize them. So let's say ideas.example.com. And the features of this application are something like recording ideas by voice. So let's say you walk around and you are a composer and you have this amazing idea of, I don't know, a tune. So you're like, remember this and I want to build a song or create a song based on this thing that I'm humming right now. So native operating system level keyboard dictation, of course, doesn't kill that use case. You need to actually record the voice and then maybe have the voice transcribed. You can, of course, also enter ideas by keyboard. So if you walk around and you have this idea for an amazing blog post or a catchy headline or something, you can just type it in. Ideas can be visual as well. So let's say you are planning your living room redesign, and you see this piece of furniture, and you draw a sketch, and I don't know, with the measures and dimensions of the piece of furniture. You want to grab ideas by photo, so you walk around and you see this amazing fabric design, you take a photo, and you just want to recall this design. And possible AI use cases. Now imagining this application that I sketched before, you could ask the thing to return all of your ideas where you hum, because this is a way to just quickly get back your composing ideas. You could tell the application, hey, based on this headline, write an opening paragraph. So just some sort of writing task. You could ask an AI, how much wood do I need given this sketch? So remember the furniture use case. Or you could say, where can I buy a t-shirt with this design? So if you have taken a photo of some fabric design, for example, you could just tell the AI, rewrite this rough idea more formally. So if you want to share it with someone, and then share this idea translated to Japanese with my friend Eiji. You could also say like, hey, summarize all my ideas that I dictated or that I entered in the application yesterday afternoon. So there's a bunch of ideas for possible AI use cases. And if you want to actually do that now and add AI to this application that I sketched, option one would be to just use something that is in the cloud. So some sort of API where you call some sort of service and then get the magic in the cloud somewhere and the results back. Positive aspect of this, of course, some of the most advanced models run in the cloud and only in the cloud sometimes even, so you get access to those. The app itself can remain small because all of the AI logic, magic, whatever you call it, is running in the cloud, so your actual application can be really small on the hard disk of the device or on the device memory. Because everything runs in the cloud, you can run on commodity hardware like lower cost Android devices, for example. You don't need high-end devices where you can run. But then the negative aspect, this can get expensive relatively fast. It makes cost prediction unclear. So if you want to offer a subscription, should you charge users 10 euros per month or $10 or whatever, or should you like make a usage-based billing, whatever? So it can be expensive and complex to calculate cost. A big privacy problem, of course, is you need to send your user data to the cloud, which can or cannot be an option. And because you need to send data to the cloud, it doesn't work offline. Which brings me to option two. You can download AI models locally and run them on the client. This is obviously privacy preserving because all the processing happens locally. It works offline once the model has been downloaded and cached. It is free to you as a developer because all the inference is happening on the user's device, so there's no cost for an API service or something. Negative aspects, of course, the model downloads can be prohibitively large and require a lot of disk space, so all of a sudden your application might require, 4 gigabytes of disk space if you ship a large, transcription model, for example, which also means this may not necessarily work on all hardware. So if you have a low-cost Android device, it may just be not fast enough because it doesn't have a powerful enough or not even have a GPU. And this also limits, to some extent, what models you can use. So if you have a model that is super proprietary, you want to super protect it from someone stealing it, this just can't work on the web because there's no way to have DRM, if you will, for AI models right now. Shameless plug to the breakout session tomorrow. So there's an idea that we have that we want to discuss with you all for this model downloads use case. So come tomorrow to the cross-origin storage breakout session. And with this, I want to move over to the proposed option 3, which is to make a shared AI model available to web APIs, which we in the Chrome team call built-in AI. It has the same, more or less, pros and cons. So privacy preserving, because all the processing happens locally. It works offline once this shared AI model is downloaded and cached by the browser. It is free to the developer because all the inference happens on the client. And then I've moved this negative aspect of the model download up a bit and made it a plus minus because it still obviously is a one-time cost. So you still need to one-time download the application. But then the idea would be once you continue with the application, of course, the model is already there. And because it's shared across all the origins of the app, of the apps that you navigate to, chances are the more popular this gets, that the model would already be there. Again, some limitations. This may not work on all hardware or be slow. And it also limits what models can be used because you're bound to whatever model the browser ships. And we see the model mostly as an implementation detail. So it should not matter really what the concrete model is because the use cases are addressed by the model in a well enough way. So that's our point of view here, but we can talk about this a little later. And we brought these ideas forward, and actually they made it into the Web Machine Learning Community Group charter at the W3C. So you can see their scope of work here. So we have so-called task-specific APIs, where there's a well-defined task like detecting the language of something, translating some input text, rephrasing input text, proofreading something that the user has written. So something that is well understood. It's a well understood task. There's no wiggle room. It's just a translation or it's just a summarization. And then the second point here is the so-called prompt API, where it's freeform. It can be anything. It can be something that is on a scale of 1 to 5, how positive or negative is this review? So some sort of classifier. It can be something that summarize this and replace every second E with whatever. So you get the point. So it's something that is just not well defined. There's a number of ideas that people might be having that we think could be realized with this API. And as I said, this work is being in the community group at the W3C. So there's some draft specs that people have come up with here. So there's the translator and language detector APIs that define the language detector and the translator API. There's the writing assistance APIs, which define the writer and the rewriter API and the summarization or a summarizer API. So you can already look at those draft specs. And then for the prompt API, we are a little bit earlier in the phase of making this something a little bit more formal. There we have an explainer so far, so you can check out the explainer. There's no spec draft quite yet. And going back to the application that I just sketched before. So if you have something like list all my ideas where I hum, this would be a task that could be addressed with the prompt API with audio input. So the prompt would be, well, list all my ideas where I hum. And then the input would be your recording ideas, like the actual recordings, like a WAV file or MP3 file or something, that you would then feed into the API, and it would come back with only the ones where you hum. So it would have an understanding of what humming is. Based on this headline, write an opening paragraph. This would be a task for the writer API. How much wood do I need given this sketch? So the furniture use case, if you remember, this would be for the prompt API. So you would give it the sketch. You would ask it this question about the sketch, and then the API would come back with hopefully a useful response. Where can I buy a t-shirt with this design? So if you have the fabric design use case, this would be, again, a use case for the prompt API with an image input. Rewrite this rough idea more formally, which would be obviously a case for the rewriter API. Share this idea translated to Japanese with my friend Eiji would be a task for the translator API. And then the last point is here, summarize all my ideas from yesterday afternoon. This would be a task for the summarizer API. So this is a little bit abstract, and I confess that it's maybe a little hard to follow. So I just thought I do a little bit of live demoing here of the implementation that we have in Chrome. So let me just move over to here. Let me increase the size here and open DevTools and increase the size here as well. So this is a super simple demo website, and I just took some text, so the bio that I used for submitting this presentation, and this is exposed to here. So here I have a global variable that gives me just the contents of this div. So the first API that I want to show you is const detector equals await language detector dot create. So now we have a language detector, and if you look at the detector, you can see it has a bunch of fields like the expected input languages and so on, but it also has simply a detect function. So I can give it my bio.inner text, and this is async, so I need to await the thing. And it gives me back an array with 2 entries. So if I open the first one, you can see with 99% confidence, it thinks that the detected language of this is English. So that's not super exciting quite yet. For reuse, let's just store this in a variable, dot detected language, and call this L. Web, yeah, const, and I think I don't need to await here. So L is now N, perfect. Okay, so now that we know that this is N, I can show you the next use case, which would be const translator equals wait translator dot create. And this is not as simple as before. So here I need to give it something where and from to translate to and from. So I need a source language, which is L that I just defined as English, or well, defined, it was detected. And then I have a target language. So obviously here we make that Spanish. And now we have a translator that can translate. So let's do just that. And we give it the bio.inner text. Again, we need to await. And then we have the result here. So Thomas Steiner es un ingeniero de relaciones con desarrolladores, blah, blah, blah. So you can see it gives me the translation back. All right, so that's this API. So language detector and translator obviously go together quite well. This is maybe Generation TikTok, so we all have an attention span of not 2 paragraphs, but maybe just a few bullet points. So let's use the summarizer for this. So we have const summarizer equals summarizer dot create. And oops, it's async. So I need to do this. So now we have a summarizer, and obviously I can fine-tune this a bit. I can tell it what kind of summaries it needs to give me. So by default, you can see the default is key points. So let's give it something to summarize, which is my bio.inner text. And oops, this is also async, so we need to await it. And then hopefully after a little bit, we get the result back. And the suspense is incredible. Come on. Be faster. Give me something back. Tempting the demo gods here. Come on, say something. So this is running in Chrome Canary, so maybe today's Canary broke it. Let's see. Interesting. So I don't get a summary back, but imagine I did. So this is live coding at its best. Maybe it will come back eventually. Maybe we just need to trigger it again. Let's see. I could, but like I want to present a lot of things, so I'm going to rush through it, and then I will answer to these kind of things later. Okay, so it seems like today's canary broke the Summarizer API. It's early days for all of those APIs, very obviously so. But yeah, so this is like two APIs that you get make sense with textual input. I want to show you another use case here, which is this one. This is actually the code of this application, so let me also zoom in a little bit. And right now, you can see down here, there's something more. So there's a prompt input field. So I can just tell me a random fact. So I can just ask it to tell me a random fact, and it spits out a random fact. So this is not very useful yet, because in many cases, you want to do something that is more customized. So this brings me to the first example here. So this is right now hooked up to, where is it? Here, script basic.js. So let me show you script basic.js. Step one for working with these APIs is npm install React. No, it's not. Step one is just essentially to, this didn't, like no one laughed, okay. You laughed when I say no one laughed. Okay, so how do you work with this? Well, you first get access to some DOM nodes here, and then just a basic event listener for the submit event. We get the prompt value that we need. We reset our inner HTML here, and then the actual magic happens in these two lines, where we have the language model that we create as before. You sort of see a pattern already, so all of those have a static method, create, and then this gives you back the thing, like the summarizer, the language model, the whatever, and then we can send, in this case, to the language model a prompt streaming prompt. All of the other APIs have streaming variants as well. I didn't show those because like it's a little bit more code. Like here you can see I need to, of course, go through this readable stream and then read chunk by chunk what is given back by the language model here. And yeah, you've seen it was sort of printing chunk by chunk the response that I came up with here, that it came up with here. Okay, so this is very simple, but now let's make this a little bit more complex. So for this, I want to move to the next demo, which is this one. So instead of the basic script, I now hook up the logic to the JSON schema one. And the idea here is we want to build some sort of classifier. So for a classifier, we just want a Boolean yes or no response, which now I can do by specifying a response constraint. And this is the simplest possible JSON schema, but a lot of the JSON schema format is supported by this, so you can make it a lot more complex. But for the sake of this simple example, I just make it a Boolean. We have the same code as before, but now for the prompt streaming, instead of just the prompt, I also add my prompt constraint. So now we force the model to respond with just a Boolean value. So if we go back to here and reload, now we need a Boolean question like, I don't know, any Boolean question that comes to mind? Will it rain today in Galicia? And it will rain today. Okay, of course, it is a language model. It doesn't have function calling quite yet, so it can't call into some sort of actual weather service. So it just, whatever, came up with a response. And I guess if you submit this a bunch of times, at some point we will get false back. So in this case, it continues to respond with true. So maybe it is true, who knows? Historically speaking, it does have some experience with it raining here. So my taxi driver to here said, in Galicia it's always raining, so it does maybe make sense. Okay, so this is step one for having a classifier. Now I want to move to the next variant of this script. So let me just hook it up to the HTML. And let me show it to you. What we have now is a reference to this image. So you can see this is the image, and I'm referencing it in this variable. And now my prompt becomes slightly more complex. So you can see now my prompt has a role of user. It's an object in an array. It has content, again an array with a type text, which is my textual prompt as before. But this time I'm also passing in an image. And then the rest is the exact same as before. Let me, for the moment, uncomment the response constraint. So now we can just get a free-form response back. So let me go to here, reload, and then I can say, is there a person on this image? And now it will hopefully respond with, yes, there's a person on the image. And yeah, like to a human, this makes a lot of sense. But yeah, it is not very useful to then sort of parse out, does it respond with yes or does it respond with no? So now it makes sense to come back with our response constraint here and say, now we want to have a true/false. So let's ask the same question, is there a person in this image? And hopefully it says true now. Yes. Okay, so you can see how this can be useful. You can make this any kind of application where you give it something and then you ask it, hey, true or false. Or you can say, like, is the mood of this positive on a range from 1 to 10? Or, like, you get the point. You can make this really free-form anything. I want to show you one more cool use case that you can realize with this. This is the prompt API connected to SQLite. So if I reload this, I can create a new conversation. And I can now say I want to add an image to this conversation. And I take the Tower of Hercules. And then I can ask it something like, describe this image to a non-sighted user. And then I can ask the AI to do that. And then it responds with, well, it got the point wrong, the Torre della Torre. That's not the Torre della Torre. But the rest seems like it makes sense. So it sort of describes what it sees on the image. And then I can also ask more things. So this is an ongoing session. So I can say, like, is this close to the water, for example? And then, oh, it gets it actually wrong. That's interesting. So including ambitious to show a park with a tower in the center and the ground below it. So it might look, like, to be fair, it sort of looks a little bit artificial because it's very mirror-y. So I guess there was some touching of this image in place. But yeah, again, you get the point. It still has the ongoing running session here. And what I can do now is I can just reload this application. So if I go here, actually I can even close it. So I can close this entire application, go back, reload it, and it has restored the session from SQLite. So it has sort of serialized the entire session into SQLite, and then I can continue where I left off, and I can ask, like, are you sure? I'm sorry, I'm not sure. So you can see it still has, even despite me having closed and reloaded the entire application, it has restored the context and so on. And I can do the chat GPT kind of thing. So I can now in parallel create a new session and I say, like, tell me a joke. And you can see how it also updates in real time here the conversation summary. And then I can switch between those and say, like, what if I give you one more hint? And then I can add another image. So this one, yeah, so this is a shot of La Coruña. And by the way, so you can see this is, it has been touched, right? You can see this is not an actual sea level image. So there has been some photoshopping happening. So I can add this image now. And I can then send this. And now it sort of corrects itself a little bit and says, yeah, now it's close to the ocean. So you can see this is all running and restoring the context. I can then go back to my jokes session and say like, well, let's do a reload in between. I can go back to my jokes session and say like, this is active now, it's yellow, and I can just ask it another, and it will tell me another joke. So you can see how this become useful, and I can actually make this completely work offline, so I can go offline now. Will Google Slides, yeah, hopefully Google Slides will still work. So I can take this entirely offline now, so closing off the Wi-Fi connection and ask it to tell me one more joke. And it will tell me one more joke. And because this is a PWA, I can even install it, close it, and hopefully, yes, we are back. So you can see how this makes sense. And by the way, something I didn't show you, it also has some session statistics. So you can, as a developer, be aware of how much the session has tokens left, how much tokens were consumed, and so on. So this is Chrome's implementation so far. I want to go back to the slides. So we have seen the live demo of this. We have seen the live demo of that. Both applications, by the way, or like this is a demo, not real super useful application, but like everything you can just access yourself and try the APIs if you set the right flags. I want to show that people actually find this useful. And we just had Google I/O. This is the full talks. If you want to get more detail, scan this QR code or enter the URL into your browser. But from this talk, I want to just show you a bunch of use cases that people have been realizing with early versions of those APIs that were made accessible to them as Origin trial. So one is a company from Japan called CyberAgent, and they run sort of like a blogging platform. So for them, it's all Japanese, so maybe someone reads it. You can start with some sort of body text, and then with this body text, click this magic button, and it will give you some heading suggestions for how to title your blog post. You get some suggestions, and then from those suggestions, you're going to say, I like this one, but make it a little shorter, for example. So it will take the existing one as input and say like, hey, take this, but make it shorter, or take this and make it more funny, or whatever. So you can see this can be actually really useful. And CyberAgent, this blogging platform, have tested this with real bloggers of theirs, so high-profile bloggers. They came to the Google office. They tested the application. They made it available to them and worked with a bunch of their top content creators, and they found it actually quite useful. Policy Bazaar is a company from India. They're in the insurance business, and they have this chat widget here. The thing is, India obviously has a lot of languages, so people would be able to type in their native Indic language. They would then use the language detector API to detect what language is the user typing in. They would then translate this Indic language to something that the support agent on the other end would speak, so maybe Hindi, maybe English. The support agent would then respond back and then translate the response back to the user's native language that was determined by the language detector API. So there's no like, hey, please type in English kind of ableist feature in this app. It's just, hey, just ask a question, and the API in the background deals with this. Nika Fashion, a company from India in the fashion business, obviously, they use the prompt API with image input to let their users say like, hey, I have this outfit and I need something that is fitting. So you can upload whatever, like these yellow, beige, whatever pants, and say like, hey, I need a sweater that goes well with it. And then the application will give you some suggestions powered by extracted features from the image. Chefkoch, a German company, they are in the business of recipes and recipes online. And what I do a lot, what my parents do a lot, we have some sort of recipe, maybe from our grandparents, that is handwritten, and we just want to digitize it. So they have this use case where they use the prompt API with image input to OCR, essentially handwritten text like this, and then make the AI make sense of it and separate in what is the ingredients, what are the preparation steps, and so on. So you can see this is also something that probably some of you can relate to as a use case. Brightsides, company working with a lot of publishers, they have this CRM, content management system, CMS, content management system, where the authors like the writers, have this internal interface. They upload an image, like in this case, these shoes, and then they can use the prompt API with image input and have an alt text suggestion generated, and then the human in the loop can say, like, yeah, this is actually a pretty adequate description that makes sense as an alt text, but they can then modify it, obviously, if it's not great. And they can also like get a figure captions, so captions for a figure are different from the alt text, so they can get both. With the prompt API, they can just tell the API what they want for this particular use case. And then the final use case here is OLX. They run a chat that also allows people to have audio messages, but this is end-to-end encrypted. And I hate when my wife sends me text messages, like audio messages. So WhatsApp sort of has started doing it, but here this is all web-based, where it will just have the local audio end-to-end encrypted still, but of course you have it on your device, and then it would transcribe on the device what people were saying. So this is a company from Brazil, so you can see this is in Portuguese here. All right, back to some of the problems with this. I said before in the minuses, like in the negative aspects, this does not necessarily run on all devices. For example, it does not run on Android right now. So Android is, of course, a very important platform. So with the Firebase team, they sat together and said, like, hey, we need some way to support Android. And they came up with what they call the Firebase AI logic, which is a hybrid experience. So it would use the built-in AI APIs if available, and if not, fall back to the cloud. So obviously, there's a big caveat. If your use case requires local processing for, I don't know, privacy reasons, for legal reasons, of course, this is not something that you necessarily can use. So careful here. It's mostly meant as a fallback logic where it can be done and where local processing is not a strict requirement. We were seeking feedback from a couple of folks and people, and some of them might be here. So there's the tag. So we filed for design feedback of the APIs. In the tag, we asked WebKit and Mozilla on their particular standards repositories. And you can see there's some discussion already happening, but obviously this is only the starting point of the discussions. And if you want to learn more about Chrome's implementation of those APIs, we have an article, Get Started with Built-in AI, or again, watch the talk from Google I/O, where I go in some more detail. And yeah, this is, as I said, not so much about Chrome's implementation. It's mostly about these APIs for the web platform. So does this make sense? And with that, I want to thank you very much for listening, and I think we have time for questions.
Thank you very much. We only have questions for two people, two questions. Okay.
Hi, nice talk. I guess my main concern is, say I'm browsing the web and a website has an origin trial. When I last tried this API, there's no kind of pop-up for the user saying Chrome is about to download 2 gigs of data or so. Will that be a thing when it's shipped?
So you mean there was no information that a model was downloading?
Yeah.
The API exposed this information from day one. I guess websites are still discovering what are best practices for exposing this. There is, when you create the object, there's a monitor that gives you information about the download progress. There's also an availability function. So if you watch the talk, I go into this in some detail. It goes into, like, maybe let's get the QR code up again if people are interested here. So there's an availability function. So you can ask it, hey, what is the availability of this thing, like the translator or the language detector or whatever. And it will then say available, which is the optimal use case. Everything is up and running, ready to go. Unavailable, this means the device doesn't even support this API because the GPU is not powerful enough or whatever. And then the two other states are downloadable, which means, yes, this device is capable. You can start triggering the download of the model, and downloading. So the download is actually right now going on or ongoing. And with this monitor, you can then hook into the event and show a nice progress bar to the user. As I said in the beginning, the motivation for these APIs to be in the browser built-in would be, once this is downloaded by one single application, all the other applications, no matter what, would profit from the download. But yeah, so I think right now this is mostly just our partners still learning how to expose this information, because in the lab, when they hack on this in a hackathon or something, yeah, of course, they never encountered a use case where the model is not ready yet, or they did it once but then forgot that this is state. So long story short, it's just poor UI, but yeah, for pardonable reasons of the customer or partner, that they haven't exposed this information yet.
So I have a question.
I don't see.
I'm here.
Here. Okay.
How do you foresee this ever becoming an interoperable web API? I think like barcode detector is an example of an API where it's reliant on some sort of device processing, but it's a fairly consistent, does this QR contain a URL, and here it is. Whereas this is, I give you free text, and the model that Chrome chooses in a specific version processes that in a specific way. And if Google decide actually we want to update that model, suddenly every website that's using it's going to start working differently. Models already, like if you're using a very specific AI model, your prompts are very specifically tailored to that AI model. And I worry that you're going to ship a specific model, people are going to be reliant on it. And then say if Mozilla want to ship their own and they're using a different model, it's just going to be, am I in Chrome, do this, am I in Firefox, do this, and potentially even versioned to browser versions from the same company.
Yeah, so my response to this is twofold. So essentially, it's different for the task-based APIs and the prompt API. So the task-based APIs are the ones where there's a well-defined task, like a translation. And people have different translation services today. So you can have human translation, machine translation. You can use different machine translating services. And there's well-defined benchmarks even for saying like, hey, how good of a translation is this? So we have agreed on judging these sort of subjective things for quality. So the vision there would be, actually just make this work well enough. And you may have noticed there's no prompt at all involved in those for the user. These APIs have been implemented by Edge, and in Chrome, what we use is Gemini Nano. What they use in Edge is Phi 4, so a model that is built by Microsoft. And they have made these APIs work. So far, they've implemented the summarizer, the prompt API, I think the writer and the rewriter API as well. And the assumption would be we can just agree on making those tasks work well enough based on existing benchmarks. We can say like, of course the output is non-deterministic, but still running a benchmark, we can say like, yes, this is a good, adequate translation of this input text. For the prompt API, it's a little bit more complex. So because the model is small, both like Phi 4, the model that Microsoft chose, Gemini Nano, there might be some more prompt engineering involved, where you sort of trigger your, or tailor your prompt to the particularities of the model that is in use. And this is a risk, and this is a true risk. So I think right now we're learning on the implementer side, how much does this actually happen, that people prompt engineer? And if we see there's a lot of prompt engineering happening, there might be just a way to fine-tune the model. So if everyone says like, please respond with yes or no, in the end, what they want to get is a Boolean response, right? So if we have this kind of thing, we can fine-tune the model and say like, hey, there seems to be a use case where people have this particular expectations. And then in the end, this led us to saying like, hey, wait, actually JSON schema might be the response here. We also have regular expression that you need to match. So over time, we think like fine-tuning the model, making it work with the use cases that we detect, having structured output as the overarching term for this, may address some of the use cases. And then lastly, and then this is where this last bullet point here, proofread input text, proofread input text came from. If we see a lot of people use the prompt API to do the same thing, we just create a higher level task API based on this. So you could be like, oh yeah, like your use case, detecting QR, not VR, QR codes, we're like, wait, a lot of people are asking the prompt API to figure out the QR code, which is like a made-up example, okay? But you get the point. Then we would say like, yeah, maybe we should just have a higher level QR code detection API on the web. And this is where the proofreader API proposal came from. So we were seeing a lot of people were using the prompt API for detecting proofreading or realizing proofreading use cases. And now we have a proposal for such an API as a high-level API. So we think on the Chrome team, the model is hopefully something that can be dealt with as an implementation detail. Of course, it's very early days, so we will see if this assumption is true. We are starting an origin trial with the prompt API with image and audio input and, of course, textual input. So people can play with this some more. Most importantly, if you go to a lot of slides, here we go. If you go to the documentation here, we have something called EPP, Early Preview Program, where we ask people to join this early preview program, which allows us then, if you join that program, to ask you and survey you about your experience with the API. So by having a back channel to the people who participate in those experiments very early on, and also like I go into some detail in this in the talk, we also invite partners, like big partners that you've seen mentioned on the slides, but also other partners that you don't see mentioned. We invite those partners into Google and also try to get addressed their use cases that they have as a big corporation, big company. But then also, as I said, the EPP is meant for developers, regular developers who just are interested in advancing these features or maybe even stopping them, who knows. So just by getting involved early on, we hope to hear a lot of feedback, survey you, address the feedback accordingly, and then launch APIs that are actually useful to people, like the task APIs, where we see, for example, Mozilla see the use case of translation on the web, and they've come up with, you might even be involved, I don't know. I don't know you, so I'm not sure if you work for Mozilla, I don't know. So there is a proposal from Mozilla, for example, for an alternative shape of the translation API, but I think in general, for the task APIs, most people would agree, sort of, on the use case of those APIs. So this was a very long-winded response. Hopefully, does it, satisfy your, okay.
Cool, thank you very much, Thomas.
Yeah, thank you very much.